Good afternoon, everybody. I hope I'm audible. So, first I welcome Abhilash, Dr. Nagendra Bhupati, and Dr. Raja Munusamy, and the coordinator, Mr. Srinivasan, to the session. Thank you, everybody, for agreeing to come today and participate in this session. On the emerging technologies, it is something which has changed. Earlier days, something new technology comes, it takes about 2-3 years. We'll understand what it is, and it will take us another 5 years before it gets industrialized. It slowly changed in the electronics and telecommunication industry, where the development started moving very, very fast. But now, in engineering industries also, I'm finding the changes are very fast and rapid. And digitalization is something which is really bringing this rapid change. Not only in engineering industry, but also in process industries like glass, in which we thought, people used to say earlier, glass making is an art. It is not a science or engineering. But we have proved it now that with the latest technology, how digital can help us improve the efficiency and operation in the plant. I think I made a small presentation that is there on this. Okay. Next slide. Can I use it? So this is Saint-Gobain for you, just one slide. I would like to just explain on Saint-Gobain. So Saint-Gobain is a French company, and today we are actually ended up this year at 55 billion euro. So we started our digital journey in Saint-Gobain. I'll just take a few slides to explain about the digital journey. So we set up our target that we would like to make something at $225 when the prices was, when the price levels were at around $280, $300 per ton. And we said we will reduce the iron content in the glass. So we set up some targets, and then we started working. What were we working before 2020 when digital was not there, and what was there after 2020, I'll explain in the coming slides. But the entire thing was done because of the employee engagement which we could achieve. And so this is how we started. So we facilitated the advancement. We started our own Index 4.0, as we call the IT division of Saint-Gobain. And today Index 4.0 serves not only India, but all the factories of Saint-Gobain, whether it is glass or abrasives or whether it is gypsum, from here. And we also have a lot of support. We set up our own research center in IIT Research Park. So we started doing a lot of work along with them. So we never thought that why should we bring research people into this or IT people into this. So we all formed a separate, it was all separate silos earlier, but all of this was combined now. And the amount of data that we get is so much. But today's modern data processing, the smallest computer can still, a chip can do the work. And we are able to develop very good algorithms and bring in results. And most of the data is stored in the cloud, so we are able to access it easily. So this is what we said. As I told you, we started thinking startup. The biggest issue was for us in implementation. So we started something called Agile. I think those in the IT industry would understand what is Agile. In the Agile program, to say in a few words, you don't make a final product. So the customer is able to see every fortnight the product as it is developing. So that if there is a change he wants, he can stop it there itself and say, this is not what we thought of. So can you make the modification instead of rejecting it at the last. And every fortnight, since you are reviewing it, there is a time period of 4 weeks, 6 weeks, depending upon the project, or 8 weeks to complete it. So this agile methodology through KPMG we started implementing across the group, in India and found a lot of success because the project started getting executed and finished. So we did, as I told you, after the project ideation, we took suggestions, best practice. It's nothing but again the same PDCA cycle. If you really look at it, it's nothing but very similar to the PDCA cycle, which we used. The technology allows us today, instead of putting it as graphs, to see it visually and continuously. It is not that the graph you have to every 1 hour, you can draw it. But today in the control room, all the parameters we can see on the computer. We are able to completely control at every stage. Even if there's the smallest deviation, we can. But this is not what we thought is going to bring us the results. I'll show you in the next slide what are the results we got. So this is what we started doing. Instead of trying to correct in the process something after the incident has occurred, we said, can we predict? So what are the failures that were taking place in the process? So we started analyzing the data in the previous 24, 48, 72 hours. And from that data, we were able to analyze that if one parameter out of the 100 parameters, so it is not that a person could see it, it is all only with computer we could do and algorithms. A small parameter which changed 48 hours before was the cause for a defect, which happened 48 hours later. So we started looking at that, and now today, as we call as the FFT method, look at these type of indicators and connect it 48 hours before so that the incident doesn't happen. And we are able to improve our efficiency by 1.5%, 2%, which is big savings for us in a continuous running industry. So this is something which was not possible earlier. Today's technology, the computers which are available, we are able to do these analysis which was impossible earlier days. Similarly, we said on automation, we did a lot of work. It's not automation for the sake of reducing manpower. This is not what we thought of. This is not what we are thinking. Our idea is to automate, to foresee, or just try to tell about that this problem is going to occur. This was more of our indication than just automating for the sake of reducing manpower. The next field that we used is in safety. The digitalization in safety, I think this is common to all industries. So we really did a lot of work on safety in digitalization. So we put CCTV camera everywhere and started tracking most of the items, all the behaviors of people, so that we are able to correct. It is not for penalizing, but for trying to correct. For example, on the forklift today, we are able to really look at it from sitting in the control room, and we found what was the issues that is coming, because forklift accidents are very common in many industries. What are the issues that are happening in the forklift? So we started guiding the forklift on a particular path. We also brought in anti-collision. So if the forklift senses, it's not necessary it should sense for another forklift. Even if it senses a human being, it will stop. The question is no longer that it is left to the man. Even if he has not seen it, if it sees it, it will stop. And these are very small technologies which are available in India. And we are able to implement that and really find a lot of improvement in the safety culture. Similarly, we said anybody authorized people only to enter. Their technology is to use the thumbprint too. And only when the thumbprint is put, the forklift will start. So many of these things we started improving. These technologies were not available earlier. I'm just trying to say some simple technologies which we implemented for safety. So what was the next thing that we did is, we said on the conveyors, I think this is another area of accident where it is accident prone. So all our conveyors today, if a human being hand goes near, below a certain distance, safety distance, the conveyor will stop. Irrespective of whether it can cause a loss to the process is secondary. Because we said human accident has to be first avoided. So first there is a warning that you are going near, there will be a bell ringing there that you are going near the conveyor. So across kilometers and kilometers of length of the conveyor, we are able to put sensors with which we are able to do. So these are the other thing on speed tracking, etc., which we did. And we put protection systems. These are all actually more of what you call bringing in mandatory chains so that the people are not able to violate safety norms. So this anti-collision which I talked to you. So you see the forklift stops on its own without any human intervention. So this is some of the small things that I thought I would just talk first before we invite our speakers. So I think we would start with Abhilash first. I think Abhilash, already they spoke about him, young engineer who's doing a lot on robotics. He has invented his own. I think he's making the first robo in India. Made in India robo, that's what I understand. And we will listen to him on what he is going to talk today. Thank you.
Good afternoon to one and all present here on dais and honorable guests and visitors. Today I am here to talk on a small topic on robotics, the next industrial revolution. These are the entire activity that we are going to discuss upon. So the global robotics position in the perspective of India and where India lies in, and why robot in the perspective of quality, and impact of variance in the perspective of customer, and frugal engineering misunderstood. So right now India has ventured into a phase where the manufacturing hub is trying to focus more on to an emerging country, and India has, after COVID, multiple companies and organizations are trying to focus on possible countries where new industries can be set up much easier, and emerging countries. And India has come into that phase where in the next 4 to 5 years, by 2028, India will become the manufacturing hub and center for the entire global market. In that perspective, robotics is one of the most key regions where quality, reliability, and efficiency comes together to determine whether this global power of manufacturing center is going to be whether in India or for that matter any other country. So whoever empowers and focus on these three factors will become the next position and the important key player in the global market. In that perspective, robots play a very crucial area. Generally, when we speak about robots, especially when we focus about articulated robots, there's a general understanding that majorly it is used for machine tending applications or welding application, and especially in India, it's considered to be more focused for welding application. But there's a very wide segment of engineering applications where it can be used, not just to replace humans, as rightly said by Aishnav sir. The application intended is more wider in the perspective of quality and efficiency. So that's the key points that we are going to discuss upon in the next few slides. So this is a graph that has been plotted. This data has been taken every 2 years. Right now, the new latest version of this data will come up in coming next few months. In this data sets, we can see the amount of installations that has been happening globally on the robotics market. You can see an increasing trend that's in the percentile scale of 10% increase in every year on year on the number of installations globally. And if you take the segments where generally the robots are installed, I'll just point it out. So if you see the two major regions where the automotive and electrical components and electrical assembly segments are the two major areas where robots are generally deployed. And India, pretty much, especially in Tamil Nadu, it's generally called as Detroit of India. So this is a zone where we have to think it through where robots are being deployed more. And if you see, generally if you take the global installation of robots, these are the two areas where robots are generally more installed at, that's on metal handling and welding applications. So this graph generally shows in the amount of installation done country-wise where the amount of robots are being installed. China right now surpasses the entire global capacity on the robotics. They pretty much exceed in scales, 6 times of the next country which installs the robot, that's Japan. And US comes in the third place, and multiple countries come fourth, and pretty much India is at almost the bottom line. So we are at 3.2% of installation in the entire global scale. That's something that very concerning. And generally, we discuss in engineering that lesson learns needs to be adopted in the shop floor, and sometimes we also adopt these lesson learns in our personal lives as well. In the last 10 years, China has grown to a scale where today, at times when we discuss manufacturing, the common mindset or the common thought that comes to our mind is that this product may be made in China. Maybe there may be quality requirements or technological requirements. A few years back, we used to discuss that China, generally it's a China product, it may not have a quality product, but right now, they have surpassed that saying, and they have gone to a scale where Chinese products are much quality products, and majority of the products that we use are manufactured in China, and that are in high quality level. So what is the lesson learned that we can see in this graph is that they have adopted the technological movement for going into automation perspective. So right now they produce robots in a scale much larger than any other country or any other company as an individual. They consume those robots in their own shop floors to automate their own productive lines and increase their efficiency, reducing the cost. So that's one of the major key points why China has become a global power in the manufacturing zone. So that is a very important keynote that we have to take into account if we want to get in the same position what China has become today. So this is an overall scale stating about the growth rate that we can see in the industry in the robotic field. So generally, when I was going through my MBA, my professor used to discuss about one key factor, that is variance. So variance is a very predominant topic that can be related with everybody's life as well as in engineering or in MBA or finance for that matter. So first we have to understand what my professor used to say to me when I was in my MBA, when I was taking care of finance in BITS. He used to give an example, I'm just quoting it to you. Generally when a person gets married, the first few months it becomes very happy, and everybody is happy along, and the entire surrounding is very prosperous, and the entire space looks like some kind of a movie. As time goes by, things goes to fades off, and there may be some problems, and eventually the life sets to a phase where they come to a normal state where the movie phase of their life tends to move out. The professor used to ask me, why do you think that has happened? There must be some kind of a cause for this. So there must be some kind of a reality on this. Otherwise, everybody's marriage would be like when they just got married from the day one, and by end of their life, maybe 30 years or 40 years, by end of that, they would have had the same feeling. He gave me an example stating that, while the day one he got married, he goes to the office, He completes his works, he ensures that everything is done in by 3:30 or 4:30, and he gets back to his house by 5:30. The individual, greets his wife and takes the day off and do all the activities. A week goes by, and instead of getting to his house by 5:30, he ends up going to the house by 6:30. Now there is a variance of 1 hour. Now his wife tends to get mild irritation. The equality or the level of uniformness in his activities has come down by an hour. As time goes by, months goes by, the variation tends to go up even further. The guy who ends up getting to his home by 5:30, now he ends up to his house by 8:30. Now the variance has gone up to a significant level, and that's how the marriage tends to also get down. So he gave this example for variance and the impact of variance in our life. Same applies to engineering, for that matter even in business. So variance is a very important factor that we have to take into account. So we are not going to discuss much in detail about the variance that you are going to see, because variance creates a lot of impact starting from the universe and the evolution that we have come to this stage. So we are going to focus on two zones of variance. So first one is variance in reference points, and variance in loading and unloading time, and what is the end outcome in the perspective of a customer. So end of the day, any organization is here to serve the customer and reap the benefit and eventually give it back to the society. So we are going to take two case studies from our own organization. So we are going to select variance in the perspective of turned parts. So I am from a background of turned parts and CNC segments. So I have a reasonable amount of knowledge on the segment of turned machine parts and how things need to be handled. So generally when we speak about variance, every single day in a machine shop, every morning meeting starts with two important decisions. One is on the quality front, that has happened in a customer complaint at the customer end. Second is the output requirement that needs to be adhered for the customer that day's output. So these two factors, believe me or not, are directly connected to the variance in a very, very impactful manner for an organization. So this particular part is one of our part that we use. It's a very important drive shaft that comes in our robot. This particular part has two reference areas for this particular bearing region and then the seating region. So it has two datum zones. So there is datum A and datum B zone available for it, but datum A has a direct interaction for concentricity in this zone. So there was a quality requirement while in assembly at our end, where the bearing seatment has a lot of problem where the insertion area doesn't go and seat in this phase. So which in turn created a runout issue on the customer end, causing improper placement in their assembly line. So we manufacture robots, right? So these components get into the robot, where this unit runs to provide a linear motion in the robot, which in turn creates angular movement in the axis that is required. So there was a lot of quality rejections on this part, and we were discussing about what was the reason, and our quality team used to point out very blankly this particular dimension 39.98 with a minus tolerance of 20 micron has surpassed the required stated dimension, creating an undersize. Eventually the bearing has is moving within the part, causing a quality problem at the customer end. But if you understand the actual reason for this, the supplier who produces this part, he has a very good control charts available, established. He notes down the inserts that has been used. So he gives proper offsets to the system, and a lot of control measures have been ensured on it. But still, this rejection tends to appear. The variance that we are here discussing about is not on the quality side of that insert or the programming, rather the individual who loads the part into the CNC. This particular dimension is controlled by the phase budding of that particular datum A. So if that individual has not placed properly in the chuck phase, or the datum is not referred properly on the chuck phase, that creates a run out on the OD. If the quality in charge in the customer end or the supplier, for instance case, the supplier end, just measures the OD, not verifying what type of an impact that has caused on the placement of the component, which will in turn result in a variance that creates a quality problem. So what I'm trying to say is that quality is not just on the dimension side or the other parameters. Fixtures and work holding is one of the crucial areas why part may not be okay for a continuous process. If you take a CPC case study for any part, if the work holding device is not proper, then the entire system fails out. Likewise, even though if there is a proper work holding device, no matter it's an hydraulic chuck or a manual chuck, if the placement of the part is not proper, once again that will create a problem. So in order to reduce the variance on the placement side, robots are one of the key implementers or the efficient part of it which reduces the variance. So I'm not saying that robots can completely eliminate this problem, but the bandwidth, the tolerance at which this can be reduced can come down. For a 20 micron part, if a person tends to place the part at a variance of 0.1, then the control chart will jump directly. So there is no logic in even discussing about that problem. So in those cases where robots needs to be deployed for a more quality approach and a quality required zone. So that's one zone why and how we can reduce variance on a turned part is one of our case studies that we did. So this is a typical situation that we used to discuss 5-6 years back when I was in the automotive segment. I'll just close by. So the inefficient operator, inefficient manager, inefficient MD, and eventually inefficient organization. That generally comes up to a conclusion because of an inefficient output. The MD or the organization is generally penalized for an improper output. So that is one zone that needs to be addressed with the help of a robot. So this is, I just also mention a point on the frugal engineering. There's just a generalized misunderstanding on the frugal engineering. This is one of the best engineering efforts done by ISRO on frugal engineering, approaching the problem without utilizing maximum amount of fuel, using orbital positioning to do this. But generally in industry, reducing cost is now considered to be as a frugal engineering. That's generally a bad approach. If the process flow is not right, even with the reduced cost, that's not going to help anybody. So when we take turned parts, gantry is generally considered to be a frugal engineered approach, but that's not going to help. So we have to, I'm running out of time, so I'm not going to explain in detail on this. Skip this some explanation on how placements can be happening and perpendicular loading becomes a problem. So I'll just explain one thing. So on a gantry, the perpendicular gantry was generally designed for parallel loading. When you go for perpendicular loading, the tensile moment that's going to act on this particular beam is going to exceed the design capability for that particular structure. So that's going to create a failure later in time, maybe in a year or so. So that's one of the reasons why gantries generally fail for perpendicular loading. So I suppose that's, so what our commitment to create a global impact? 3 years back, 4 years back, while we moved into the robotics market, why we wanted to manufacture robots, the Indian market tends to produce and needed to produce more quality products, but the cost involved in producing or getting the robots for their shop floor is very high. So we took a decision and we invested a lot of money and effort in creating robots and engineering products on that. And eventually we created a company that produces robots within India, and we are one of the only company in India which produces robots. We have gone through a lot of engineering efforts and requirements so that the Indian people can reap the benefit, and the engineering knowledge doesn't come much easier for the robotic industry. We had gone through a lot, but we are determined to deliver the required product for your shop floor to enhance your productivity. So that's our commitment from Ace Robotics. We produce at 1/3 of the price for an imported robot. So I'm just keeping all these activities. This is general approach of how robots being deployed in a typical shop floor. And a placement approach, how we apply frugal engineering to get a reduced cost but the same output where we go for an imported robot. These are some of products. I suppose. Thank you. Thanks for the opportunity.
I think today medical is no longer, there's a lot of engineering in medicine now. There's so much of gadgets and maybe it's better than the robot.
Good afternoon. Thank you for this opportunity, NIQR team. I am the odd one out in this particular arena. பல சிங்கங்கள் இருக்கிற இடத்துல ஒரு ஆடை விட்டால் என்ன ஆகுமோ அந்த நிலைமை எனக்கு வராதுன்னு நினைக்கிறேன். Hope so. ஸோ இது எதுக்கும் என்ன குரல் நம்பர் 1, it was made in Mac. When it transferred into Windows, it got it like that. அகர முதல் எழுத்தெல்லாம் ஆதி பகவன் முதற்றே உலகு. So I'm going to discuss about advances that has happened in the field of cardiology and some allied specialties. சத்தியமாக 15 நிமிஷம் பத்தாதுங்க கார்டியாலஜி பற்றி பேசுகிறதுக்கு. ஸோ நான் கார்டியாலஜி தவிர சில துறைகளை பற்றி பேசணும் அப்படின்னா எனக்கு இன்னும் கொஞ்சம் டைம் தேவைப்படும். அதர்வைஸ் ஐ ஹேவ் டு ரஷ் ஃபாஸ்ட். ஸோ கார்டியாலஜி மெடிசன், இந்த ஃபீல்ட் ஆஃப் மெடிசன் இதயவியல் தான் ஃபஸ்ட்டு கண்டுபிடிச்சது. வில்லியம் ஹார்வே 16th centuryயில் blood is continuously circulating inside our body. 16th centuryயில் வரலாறு முக்கியம். History is very important. So in this advancement I am going to give some history also. Cardiology is the most fascinating part of medicine. Extremely fascinating. You will see the cure then and there itself. Ventricular tachycardia, ventricular fibrillation னு சொல்லுவோம். பின்ன என்னென்னா இதய துடிப்பு நார்மலாக 60 to 100 இருக்கிறது 300 600ன்னு இட் ஸ்டார்ட் பீட்டிங். அப்போ அந்த பேஷண்ட் கரெக்டாக கண்டுபிடிச்சி ஈஸி எடுத்து டாக்குமெண்ட் பண்ணிட்டு பட்டுன்னு ஒரு ஷாக் கொடுத்தோம்னா கப்புன்னு எந்திரிச்சு உட்காருவார். அந்த ஃபீல் தான் தட் மேட் மீ டு என்டர் இன் டு கார்டியாலஜி. தட் வில் நாட் பி அப்ளைட் இன் எனி அதர் ஃபீல்ட் ஆஃப் மெடிசன். ஸோ ஹிஸ்ட்ரி, லெனக் இப்படி தான் ஃபஸ்ட்டு ஹீ ஸ்டார்டட் ஆஸ்கல்டேட்டிங் த செஸ்ட். வி நோ த மாடர்ன் செஸ்ட். Serendipity. Medicine is actually serendipity. William Röntgen end of 19th century, அந்த எக்ஸ்ரே அவங்க ஒய்ஃபோட எக்ஸ்ரே திடீர்னு கண்டுபிடிச்சார். என்ன ரேஸ்ன்னு தெரியல, அதுக்கு பேர் எக்ஸ்ரே, எக்ஸ்ன்னு வச்சுட்டார். எக்ஸ்ரேஸ் இன்னைக்கு கார்டியாலஜியில் இருக்க எல்லா ப்ரொசீஜர்ஸும் எக்ஸ்ரே பேஸ் பண்ணி தான் இருக்குது. எனி இமேஜிங் இட்ஸ் பேஸ்ட் ஆன் எக்ஸ்ரே. There are no more X-rays, there are electron rays, there are no more X-rays though. He was awarded Nobel Prize for the same. The cardiology field was actually born when we invented blood pressure. இங்கே உட்காந்துட்டு இருக்க ஒரு 500 பேத்தில் பிபி மெஷர் பண்ணோம்னா ஐ எம் பிரிட்டி ஷுர் 30 to 40% of individuals will have high blood pressure. They may be either taking tablets or they will be diagnosed new. I can assure you that. That is the prevalence of hypertension in our community. இப்போ இந்த மாதிரி ஆயிடுச்சு. இதுக்கெல்லாம் காரணம் உங்களை மாதிரி இருக்கிற இன்ஜினியர்ஸ். அவ்வளோ பெரிய இன்ஸ்ட்ருமெண்ட்டை இவ்வளோ சிறுசாக எங்களுக்கு கொடுத்துட்டீங்க. தேங்க்யூ. நாங்கள் பாக்கெட்லேயே வச்சு எடுத்துகிட்டு போகிறோம். இப்போ 8th one 1903 இசிஜி எடுக்கிறார். இது எத்தனை பேர் இசிஜி எடுத்திருப்பீங்க? ஒரு 20% எடுத்திருப்பீங்க. இல்லை இசிஜி ஒரு 10% கையை தூக்குறீங்க. ஓகே, வெரி குட். இப்படி தான் ஃபஸ்ட்டு இசிஜி எடுத்தார். 2 வாளிக்குள்ளே தண்ணி இருக்க வாளிக்குள்ளே காலை வச்சுட்டாரு, இன்னொரு தண்ணி இருக்குள்ள வாளிக்குள்ளே கையை வச்சுக்கிட்டாரு. அப்படி தான் எடுத்தார். இவருக்கு நோபல் ப்ரைஸ். இப்போ எங்கள் இசிஜி மிஷின் இந்த மாதிரி. தேங்க்ஸ் டு யூ கைஸ். நாங்கள் வந்து கன்சியூமர், வி ஆர் கிவிங் இட் டு த பேஷண்ட்ஸ் and the technology is developed by engineers like you. There's a collaboration that has to happen symbiotically between the field of medicine and engineering so that we can effectively treat our patients in a better way. இவர் ஒரு crazy guy. He is called as William Fossman. 1929ல அவர் என்ன பண்ணாருன்னா, அவர் வந்து யூரோலஜினா the field of medicine that takes care of kidney, urinary bladder and prostate and urethra. யூரின்ல போகிற டியூப் எடுத்துகிட்டு போயிட்டு கையில் இங்கே அவரே கட் பண்ணிக்கிட்டு டியூப் உள்ளே விட்டுட்டு ஓடியா போயிட்டு எக்ஸ்ரே எடுத்துகிட்டு எனக்கு கண்டிப்பாக இங்கே போடுற இது ஹார்ட்டுக்கு போகும், அது எக்ஸ்ரே தெரியும் அப்படின்னு ப்ரூவ் பண்ணார். He was rusticated from the university because he did something that can harm an individual. 20 years later, he became a dentist and the Nobel Prize committee searched for him and gave the Nobel Prize. So something crazy can happen, but be careful. இந்த மாதிரி தான் கார்டியாக் கத்தீட்ரேஷன் ஆரம்பிச்சு இதுதான் இப்போ எங்களோட கார்டியாக் கத்தீட்ரேஷன் லெபார்டரி. It's very costly. However, the equipment is so fantastic that we can do even smaller 0.3 millimeter வரைக்கும் எங்களால் பார்க்க முடியும் இந்த எக்யூப்மெண்ட்ஸில். இவர் ரொம்ப முக்கியமான பர்சன், அலெக்சாண்டர் ஃப்ளெமிங். Just like the person Edward Jenner who principally invented vaccination, Fleming invented antibiotics, a new medicine, new field, completely new field. அவர் இல்லைன்னா antibiotic field இருக்காது. All of us might have got some amount of infection in our part of life and many of us might have succumbed or developed some kind of morbidity. We should thank him. Newer antivirals, இது history, அதுக்கப்புறம் நிறைய antivirals, நிறைய antifungus எல்லாம் வந்துட்டு இருக்கு. Thanks to the biomedical engineers, pharmaceutical engineers, everyone who are helping us to create the progress in the particular field. Gibbon, நிறைய பேர், சில பேத்துக்கு இங்கே ஹார்ட் ப்ரொசீஜர்ஸ், மேஜர் ஹார்ட் பைபாஸ் சர்ஜரி ஆயிருக்கலாம். இவ்வளோ பெரிய மிஷின் இருந்துச்சு முன்னாடி, இப்போ வந்து ஆல்மோஸ்ட் இந்த லேப்டாப் அளவுக்கு மிஷின் வந்துருச்சு, ஹார்ட் பைபாஸ் மிஷின். இப்போ இதுதான் கன்வென்ஷனல் பைபாஸ், இது ஒரு ரியல் பேஷண்ட்டோட சர்ஜரி. இட் வாஸ் டன் லாஸ்ட் வீக். இந்த மாதிரி தான் ஹார்ட்டை செஸ்ட் ஓப்பன் பண்ணி, நான் ஃபுல்லாக காமிக்கல, மெனி ஆஃப் யூ கான்ட் see it. இப்படி தான் ஹார்ட் ஓப்பன் பண்ணி நாங்கள் ஒர்க் பண்ணுவாங்க. நான் ஒர்க் பண்ண மாட்டேன், ஐ எம் கார்டியாலஜிஸ்ட், கார்டியோதொராசிக் சர்ஜன், இப்படி தான் ஒர்க் பண்ணுவாங்க. ஸோ நான் ஏற்கனவே சொன்னேன், 300 to 600 டைம்ஸ் ஹார்ட் துடிக்கிறப்ப டப்புன்னு சினிமாவில் நீங்கள் பார்த்துருப்பீங்க, ஷாக் கொடுப்பாங்க. அதே தான், அந்த மிஷின் தான் இந்த மிஷின். 1947 கண்டுபிடிச்சாரு. இப்போ அந்த மிஷினோட சைஸ் இந்த சைஸ். ஸோ ஃபினாமினல். இப்போ இது வந்து இசிஜி கனெக்ட் பண்ணணும், ஆட்டோமேட்டட் எக்ஸ்டர்னல் டிஃபிபிரிலேட்டர் ஏஇடி மிஷின்ஸ்னு எங்கெங்கெல்லாம் மால்ஸ் இருக்குது, எல்லா ஃப்ளைட்ஸ்லேயும் இருக்கும், போலீஸ் ஸ்டேஷன்ஸில் இருக்கணும், எங்கெங்கெல்லாம் மக்கள் க்ரௌடடாக இருக்காங்களோ அங்கெல்லாம் இருக்கணும். ஸோ அந்த பேஷண்ட் யாராச்சும் கீழே விழுந்துட்டாங்கன்னா, நிறைய வீடியோஸ்லாம் பார்த்துட்டு இருக்கீங்க, நல்லா நடந்துட்டு போயிட்டு இருப்பாங்க, டபக்குன்னு கீழே விழுந்துருவாங்க, இறந்து போயிடுவாங்க. ஸோ லக்கிலி இஃப் ஒன் ஆஃப் யூ அரவுண்ட், யூ நோ CPR is very essential. Go there, just give compression to the heart, we can save the life. அந்த மிஷின் இருந்துச்சு அப்படின்னா, அந்த மிஷினை பறக்கணும், மேலே ஃப்ரண்ட்டில் ஒன்று பேக்கில் ஒன்று ஒட்டி போட்டு நீங்கள் எதுவுமே பண்ண வேணாம், ஒட்டி போட்டிங்கன்னா அதுவே அனலைஸ் பண்ணும், ஷாக்கபிள் இருத்தமா நான் ஷாக்கபிள் அதுவே கண்டுபிடிக்கும், then it will deliver the shock. Even if you may be the king of an empire, you cannot be salvaged if the particular shock cannot be delivered. So time is very crucial. So thanks to engineers who made this equipment. இவர் தான் ஃபாதர் ஆஃப் இன்டர்வென்ஷனல் கார்டியாலஜி, வேர் ஐ ஆம் அ பார்ட் ஆஃப் இட். ஸோ 1977 ஃபஸ்ட்டு ஹார்ட் செஸ்ட் ஓப்பன் பண்ணாமல் லெட்ஸ் ஓப்பன் த வெசல். ஆண்ட்ரியர் குட்ஸிங், he was originally a Swiss citizen, later moved to US and he died in a flight accident. He's a crazy guy who he's a pilot himself. This is the way how do we do angioplasty. Just for want of time, I am going to run fast.
Secondary to several risk factors, some of which are cigarette smoking, hypertension, hyperlipidemia, and diabetes.
I'm going to give the audio for this video alone because it's very, very important. So what are the risk factors for heart? Bonus to education, hypertension, diabetes, smoking, being sitting in a chair which is called as new passive new smoking. And this is the way how the blood vessels flows through the heart vessels.
During a percutaneous coronary intervention, an incision is made to isolate the femoral artery.
So these days we don't go through the legs, we go through the arm blood vessel, either left arm or the right arm, mostly through right arm.
A catheter is inserted into the artery and guided up the aorta to the heart.
The procedure பண்றது என்னமோ நாங்க தான், but invent பண்ணத equipments எல்லாம் நீங்க தான்.
Guide the catheter to the obstructed coronary artery. Radiopaque dye is injected into the artery. Imaging determines the location of the stenosis and the diameter of the vessel. Once the vessel is isolated and the obstruction located, a guide wire is threaded through the catheter to the location. The catheter is removed, leaving the guide wire. A balloon catheter is pushed over the guide wire and centered over the blockage.
We are expanding the vessel
by
putting
open
a
the
balloon.
narrowed vessel. The balloon is inflated and deflated multiple times to gradually widen the occluded vessel. To ensure that the artery remains unobstructed, a second balloon catheter with a stent is threaded to the location. The balloon is inflated, expanding the stent.
A coronary stent is a metallic product which is made predominantly of multiple alloys, mostly from cobalt chromium, with a polymer to carry a drug, and the drug that decreases further proliferation of cells inside the stent, which we call it neointimal proliferation, hyperplasia. This is the most commonly utilized medical device in the world
For some
in human
patients,
being.
drug-eluting stents are used to decrease the chances of in-stent stenosis.
Okay, this is what is called as angioplasty or PCA or stenting. This is the way how we go through the leg or through arm and inject something called as a dye, which is an omnipack. I request the engineers to come with a dye which can create much less damage to the patient, which could be utilized. The omnipack is the dye, visipack is the dye, kidney problem இருக்கிறவங்களுக்கு நிறைய யூஸ் பண்ண முடியாது. So the scientific committee, scientific scientists are in the motion to identify a product that could be utilized in such patients also. So கருப்பு கலர்ல தெரியுது எல்லாமே blood vessels தான். No need to go in detail about this. This is called as coronary angiogram. Initially சிம்பிளான கேசஸ்க்குலாம் பண்ணிட்டு இருந்தோம். As we grow older and older, our population will also become older and older. So the vessels அங்கெல்லாம் வந்து கொலஸ்ட்ரால் போய் டெபாசிட் ஆனது, நிறைய கால்சியம் வந்துருச்சு. கால்சியம் வந்து நம்மளுக்கு தெரியும் கல் இருக்குது அப்படின்னா சுத்தினா கல் உடையும். So we are going to அதே பிரின்சிபல் யூஸ் பண்ணோம் இங்க. We utilize something called as, you can see olive says burr here, a rat tail appearance. அதுக்கு ஃப்ரண்ட்ல diamond spicules இருக்கு. It's called as rotablation. So we go with 16,000 to 18,000 RPM per minute, so that we cut those calcium. Once the calcium is cut, then we can put our stent and expand the vessel in a safer way. This is one such patient where the procedure was done. So this is called as rotablation. This is an advanced procedure. First came in 1989, went away and came out of market little bit and came back again quite rapidly after 2010. So angiography, rotablation, அடுத்து ultrasonography. நிறைய பேர் இங்க ultrasonography பண்ணிருப்பீங்க, வயித்துக்கு ultrasonography ஸ்கேன் பண்ணுவீங்க. அதே மாதிரி ஹார்ட்டுக்கும் அல்ட்ராசோனோகிராம் ஸ்கேன் பண்ணலாம். ஸோ ஆஞ்சியோகிராம் வந்து ஒரு 2-dimensional ஸ்ட்ரக்சர். நம்ம ஒரு ஆங்கிள் இருந்தால் பார்ப்போம். ஸோ 2-dimensional ஸ்ட்ரக்சர் ஹஸ் காட் அ இன்ஹெரண்ட் லிமிடேஷன். ஒரு பக்கம் லீஷன் டைட்டாக இருக்குது அப்படின்னா எங்களுக்கு மிஸ் பண்ணிடுவோம் நாங்கள். ஸோ இன்ட்ராவாஸ்குலர் அல்ட்ராசோனோகிராம்ல we take a catheter and do ultrasonography of the vessel and see directly what exactly like this inside the blood vessel. It's called as intravascular ultrasonography. If you use something called as light, infrared waves, then it is called as optical coherence tomography. Optical coherence tomography. So இது எல்லாமே ஹார்ட்டுக்குள்ள blood vesselsல பண்ணுவோம். அந்த மாதிரி பண்ணோம்னா this is one such patient where angiography பண்றோம். இங்க நல்லா க்ளீனா இருக்கு, ஆனா இங்க பாத்தீங்கன்னா கொஞ்சம் கொசகொசன்னு இருக்கும். இந்த இடத்துல கொஞ்சம் கொசகொசன்னு இருக்கு. அந்த கொசகொச அது எதனால இருக்குது, அது சேஃபா பண்ணலாம், எதுக்கு பேஷண்ட் சிம்டம் வருது அப்படிங்கிறதுக்காக அந்த ஓசிடிங்கிற டெஸ்ட் பண்ணோம். அந்த ஓசிடிங்கிற டெஸ்ட் பண்ணதுக்கப்புறம் எங்களுக்கு இந்த மாதிரி ஒரு பிக்சர்ஸ் கிடச்சி. இதுதான் வந்து லோட்டஸ் ரீஃப் அப்பியரன்ஸ், தாமரை இலைமேல் இருக்க தண்ணீர் அப்பியரன்ஸ் அப்படின்னு சொல்லுவோம். அது ஏற்கனவே அவருக்கு ஹார்ட் அட்டாக் ஆகி அந்த ரத்த கட்டி சேர்ந்து காட் வில்லிங் ஹியர் அந்த ரத்த கட்டியில் சில பிளட் வெசல்ஸ் ஃபார்ம் ஆகி அதில் ரீகேனலைஸ் ஆகிடுச்சு. அதான் ரீகேனலைஸ் த்ராம்போஸ் சொல்லுவோம். ஸோ இந்த மாதிரி அவருக்கு இருக்குது. இது அதுக்கப்புறமேட்டு அவருக்கு ஆஞ்சியோபிளாஸ்டி பண்ணிட்டு we were able to treat him. So in addition to utilizing angiography, which is there for last 5 decades, now we are doing IVAS and OCT, which is there for last 2.5 decades. OCT is there for last 1 decade. So இந்த மாதிரி ஓகே ஸ்டென்ட் போட்டதுக்கு அப்புறம் அதை நல்லா ஆப்டிமைஸ் பண்ணணும். எவ்வளோக்கு எவ்வளோ நல்லா விரிச்சு விடுறோமோ அவ்வளோக்கு எவ்வளோ நல்லா இருக்கும் ஸ்டென்ட்ஸ். So we are looking into the stents whether they have been expanded well or not. If they are expanded well, we will see it as white color. If they are not expanded, we can see it as red color. So எங்கெங்கெல்லாம் ரெட் இருக்கோ அங்கே திருப்பி பலூன் எடுத்துகிட்டு போய் we will dilate and oppose it well. ஓகே, பனைமரத்து கீழே பால் குடிச்சவெல்லாம் கல்லா இல்லை. ஸோ அதே மாதிரி பிளாக்கேஜ் எல்லாத்தையும் ட்ரீட் பண்ணணுமா? டெஃபினட்டாக தேவையில்லை. there's a special technology which is available, which we put a wire into your heart, into the blood vessel. I identify whether the lesion needs any intervention, bypass surgery தேவையா, angioplasty தேவையா பார்ப்போம். ஃபார் எக்ஸாம்பிள் இது வந்து ஒரு 8 வருஷம் ஆச்சுங்க. ஒரு காரைக்குடியிலேருந்து ஒரு அம்மா வந்திருந்தாங்க. இதுதான் ரைட் சைட் பிளட் வெசல்ஸ், டேக் இட் ஃப்ரம் இது லெஃப்ட் சைட் பிளட் வெசல்ஸ், ஃப்ரண்ட்ல இது லெஃப்ட் சைட் பேக் சைடில் போகிற பிளட் வெசல். எல்லா இடத்துலையும் பிளாக்கேஜஸ் இருக்குது அந்த அம்மாவுக்கு. ஸோ ரைட் சைட் பிளட் வெசலுக்கு ஒரு ஸ்பெஷலாக உள்ள ஒரு ஹார்ட்டுக்குள்ள வயரை விட்டு அங்கே லீஷன் சிக்னிஃபிகண்ட்டாக இல்லையான்னு செக் பண்ணோம். இந்த வேல்யூ 0.8க்கு கீழே இருக்குது அப்படின்னா அது சிக்னிஃபிகண்ட். 0.8க்கு மேலே இருந்தால் அதுக்கு எதுவும் பண்ண வேணாம், மாத்திரம் இருந்தே போதும். அதனால் அந்த பேஷண்ட்டுக்கு பைபாஸ் சர்ஜரி அனுப்பல. 2 ரத்த குழாய்னா பைபாஸ் தேவையில்லை. ஆஞ்சியோபிளாஸ்டி, இந்த ரோட்டாபிளேஷன் ஏற்கனவே காமிச்ச அதே வீடியோவில் அந்த கால்சியத்தை எடுத்துட்டு ஸ்டென்ட் போட்டோம். ஷீ இஸ் டூயிங் ஃபைன், ஷீ இஸ் அலைவ் ஈவன் நவ், டூயிங் வெரி குட். இந்த மாதிரி இது எல்லாமே ஹார்ட்டுக்கு மேலே இருக்கிற ரத்த குழாயில், ஹார்ட்டுக்குள்ள ஹார்ட் மசில் ஹார்ட் வேல்வ் வர ப்ராப்ளத்தை ஸ்ட்ரக்சரல் ஹார்ட் டிசீஸ் சொல்லுவோம். இட் இஸ் வெரி ரேப்பிட்லி இவால்விங் ப்ரொசீஜர். பயங்கர ஐ வுட் சே ஃபினாமினலி இவால்விங். முன்னாடியெல்லாம் ஒரு ஹார்ட்டில் அயோட்டிக் வேல்வ் ஒரு வேல்வ் இருக்குது. ஹார்ட்டுக்குள்ள வர பிளட்டு அந்த அயோட்டிக் வேல்வில் கடந்து தான் உடம்புல எல்லா இடத்துக்கு போகணும். As we grow older and older, more than 80 years, 10% will have this problem, aortic stenosis. அந்த ப்ராப்ளத்தெல்லாம் முன்னாடி ஹார்ட்டை ஸ்டாப் பண்ணி வேல்வை மாற்றி சேஞ்ச் பண்ணுறோம். அந்த மாதிரி தான் சேஞ்ச் பண்ணுறோம். இப்போ ஆஃப் லைட் அந்த மாதிரி பண்ணுறது இல்லை. என்ன பண்ணுறோம் அப்படின்னா கால் வழியாகவே போகிறோம்.
aortic valve that's not opening
Valve
well,
ஒழுங்கா
it's
சுருங்கல
severely
பாருங்க.
calcified. To perform the TAVR or transcatheter procedure, a wire is inserted in the femoral artery. It is threaded up through the aorta and around the aortic arch. And then that wire is passed through the stenotic
எல்லாமே
aortic valve.
3 to 4 millimeter
placed
ஹோல்ல
in the
பண்றது.
left ventricle.
Thanks to engineers like you who invented it, who helped
Following
us
that,
making it.
a balloon catheter is passed over the wire into the stenotic aortic valve. The balloon catheter is then inflated, opening up the
பலூன்
stenotic
வச்சு அந்த
valve,
valve விரிச்சு
cracking
விடுறோம்,
the
space
plaque,
create பண்றோம்.
and freeing up the leaflets on the aortic arch,
அதுக்கப்புறம் அந்த valve எடுத்துட்டு போறோம்.
pushing the
valve இங்க
diseased
வச்சு விரிச்சு
leaflets
விட்டோம்.
out of the way.
முன்னாடி எப்படி valve ஓபன் ஆயிடுச்சு உங்களுக்கு தெரியல. முன்னாடி valve இப்படி ஓபன் ஆயிட்டு இருந்துச்சு.
Is restricted
இப்ப valve விரிச்சு விட்டதுக்கு அப்புறம் valve நல்லா
flow
ஓபன் ஆகுது.
through the valve.
இந்த மாதிரி ஓபன் ஆகுற valve மோசமா இருந்துச்சு. இந்த ப்ரொசீஜர் பேர் தான் TAVI, transcatheter aortic valve intervention னு சொல்லுவோம். ஒரு எக்ஸாம்பிள் 83-year-old இது யாருக்கு பண்ணுவோம்னா எல்டர்லி பேஷண்ட்ஸ் 65 வயசுக்கு மேல ஓபன் ஹார்ட் சர்ஜரி வேணாம்னு நினைக்கிறவங்களுக்கு நாங்க பண்ணுவோம். எல்லாத்துக்கும் சின்ன வயசுல இருக்கவங்க பண்ண மாட்டோம். சின்ன வயசுல இருக்கவங்க இந்த ஓபன் ஹார்ட் சர்ஜரி தான் தீர்வு. CT scan again because of engineers like you இப்போ CT scan பண்ணால எங்களால பெர்ஃபெக்ட்டா anatomy இந்த வால்வுக்கு இந்த சைஸ் தான் போடணும், இந்த ப்ராப்ளம் ஆன்டிசிபேட் பண்ணலாம், இதெல்லாம் எங்களால ஜட்ஜ் பண்ணி பண்ண முடியுது. கால் வழியா பண்றதுனால காலுக்கு போற ரத்த குழாய் நல்ல சைஸ்ல இருக்கான்னு பார்த்துட்டு பண்ணுவோம். ஸோ இது வந்து ஒரு ஒன் இயருக்கு முன்னாடி பண்ணது. I don't want to show the blood and all to you. That is part of our life. I don't want you to have that feeling. ஸோ இந்த பேஷண்ட்டுக்கு ரத்த குழாயிலையும் அடப்பு இருந்துச்சு, அயோட்டிக் வேல்வ்லையும் அடப்பு இருந்துச்சு. அவருக்கு இங்கே பார்த்தீங்கன்னா ரைட் சைடு ரத்த குழாயில் ஆன்ஜியோ பண்ணி பார்க்குறோம். நல்ல கால்சியம் படிஞ்சு ரத்த குழாயில் அடப்பு இருந்துச்சு. அந்த ரோட்டாப்லேஷன் அகைன் அந்த கால்சியத்தை எடுக்க ரோட்டாப்லேஷன் பண்ணிவிட்டு ஸ்டென்ட் பண்ணிவிட்டு ஐவஸ் பண்ணி அந்த ஸ்டென்ட்டை நல்லா விரிச்சு விட்டுருக்குமான்னு கன்ஃபார்ம் பண்ணிவிட்டு அதுக்கப்புறம் அடுத்து அகைன் டெக்னாலஜி வால்வ் விரிச்சு விடுறப்ப அங்கேருந்து சில கால்சியம் வந்து மூளைக்குள்ள போச்சுன்னா பக்கவாதம் வரும். பேஷண்ட் கேன் டெவலப் ஸ்ட்ரோக். அதை ப்ரிவென்ட் பண்ணுறதுக்காக ரைட் சைடு கைவழியா போய் இன்வெர்டட் அம்பர்லா ஷேப் டிவைஸ், இந்த தெரியுதா உங்களுக்கு, இன்வெர்டட் அம்பர்லா ஷேப் டிவைஸ், இட் இஸ் கால்ட் சென்டினல். ஏதாச்சும் வால்வ்ல இருந்து பிரெயினுக்குள்ள போச்சுன்னா அதை பிடிச்சிக்கிறோம். அது அந்த டிவைஸ் போட்டு பிரெயினை ப்ரொடெக்ட் பண்ணிடுவோம். அதுக்கப்புறம் வால்வை கிராஸ் பண்ணி we are putting the valve align பண்றோம். Yeah, now the valve is deployed. You can see that previously it was not seen. So the valve is deployed. He is doing fine. So முன்னாடி day 1 surgery patient இப்படி இருந்தாங்க, இப்போ day 1 surgery TAVIக்கு அப்புறம் இப்படி இருக்காங்க. Thanks to the technology and the scientists who are involved. அடுத்து ஹார்ட்டுக்குள்ள, sir may I have time sir? 2 minutes, okay. ஸோ ஹார்ட்டுக்குள்ள பக்கவாதம் ஸ்ட்ரோக் வந்துச்சு. ஒரு முக்கியமான காரணம் வந்து ஏட்ரியல் ஃபிப்ரிலேஷன். இந்த இடத்துல லெஃப்ட் சைடு ஹார்ட்டில் ஒரு சின்ன சேம்பர் இருக்குது, அது பேர் லெஃப்ட் ஏட்ரியல் அப்பண்டேஜ்னு சொல்லுவோம். ஏட்ரியல் ஃபிப்ரிலேஷன் இருந்துச்சுன்னா அங்கே கிளாட் ஃபார்ம் ஆக வாய்ப்புகள் இருக்குது. ஸோ என்ன பண்ணுவோம்னா கால் வழியாக ரைட் ஹார்ட்டுக்கு போயிட்டு அதுலேருந்து லெஃப்ட் ஹார்ட்டுக்கு சின்னதாக துவாரம் போயிட்டு, இதுதான் ரைட் சைடு ஹார்ட்டு. அந்த ரைட் சைடு ஹார்ட் வழியாகவே சின்னதாக ஒரு துவாரம் போட்டு லெஃப்ட் சைடு ஹார்ட்டுக்குள்ளே போய் அந்த சேம்பருக்குள்ள என்ன சைஸ் அதெல்லாம் பார்த்துட்டு அங்கே ஒரு டிவைஸ் போட்டு வந்துடுவோம். இது பேர் எல்ஏ அப்பண்டேஜ் க்ளோஷர். இது எல்லாமே வந்து தேங்க்ஸ் டு அவர் கம்யூனிட்டி, மெடிக்கல் கம்யூனிட்டி, வி ஆர் ஏபிள் டு பெர்ஃபார்ம் எவ்ரி திங் இன் அவர் ஓன் கண்ட்ரி. அடுத்தது நார்மலாக தேங்க்யூ. ஸோ பிகாஸ் ஆஃப் டைம் கன்ஸ்ட்ரைன்ட் ஐ வுட் லைக் டு ஸ்டாப் வித் த ஃபைனல் ஸ்லைட். Okay, so how we are ahead? My crystal ball is I don't know whether most of us will be alive 25 years from now, but there won't be any devices. We will be treating genes. There's something called as CRISPR. I think that is already came into existence where we go and give an individual an enzyme. That enzyme will go and target that particular deficient DNA, cut the DNA and give a new DNA so that the individual can develop a proper functioning protein. That is going to come in future for sure. There's no doubt about it. That's a part of genetic therapy. Artificial intelligence is going to come into a significant role. I didn't go into the robotics. It's still evolving in the field of medicine, especially in the field of cardiology. And as far as India is concerned, we need more such equipments where there's an amalgamation of medicine and surgical field that will give better patient outcome, which is much more cost effective as compared to imported equipments. Thank you.
I think in just 15 minutes you spoke so much about cardiology. Excellent. So now I would request Dr. Raja Munusamy, he's from Reliance. He's going to talk on the development in Reliance.
I have been given a 15 minutes time. Probably I can talk about 15 hours on this, because what we are going to discuss about is 100 years what we are going to do, how we are going to have a sustainable, cleaner mobility solutions. Okay, that's what the topic is. But I've been given 15 minutes or 10 minutes. It shows 10 minutes. 10 minutes. 15 minutes. Okay. So now there is a quality, reliability. Earlier people used to focus on only material, mechanical related. After that it came mechatronics, electronics got added. Now it became a chemitronics. After some time, now itself added artificial intelligence. So it becomes so complex. So probably accordingly the quality assurance process, reliability process also has to be improved. We have to keep looking for these challenging technology aspects, and we have to develop a process and also process for making it better. Okay, so with this, let me start with the note. There are cleaner mobility is an option. Okay, why do we need to have a cleaner mobility? Already we are having a BS6. There is a big chemical factories around the engine, all exhaust gas treatment we are doing. Can we get away with it? One is getting away with the emissions. Second aspect is reducing the imported crude from foreign. Can we have our own? Yes. Are there any solution? Yes, there is a solution. So that is where harnessing renewable energy from solar, using solar panels. Today, you know what is the cost of energy which we get out of solar panels? It's 1.9 rupees. Probably after 2-3 years, it will become less than 1.5 rupees per unit. But still we are paying 6 rupees, 7 rupees per unit. That's why I am suggesting all of you go for harnessing solar energy, putting UPS, it's worthwhile. Instead of paying 6 rupees, 7 rupees, 8 rupees per unit, better go for solar panel, put a battery, use it, optimize it, plan your energy, run your washing machines during daytime only, run your AC daytime completely, and night time just use fan alone. So by this way, you can manage. I reduce my power electricity cost from 5,000 rupees per month to 500 rupees in Bangalore. Okay, so it is possible. This is my tip for energy conservation, making it cleaner, sustainable, and also you can save money. Your return of investment is within 3 years you can get back your money. Okay, so this is what the kind of solution which we can look for. So as part of this, in mobility solution, what we are going to do? See, now there are various technology options are there. EV is the one. Probably while I was with Tata's, I was working on Nexon EV. People are making a joke out of it. But today that is more than 1 lakh vehicles are there on the road. So running cost is hardly 75 paise. It's economically viable. So probably I'm going to highlight what is the kind of scenario which we are going to have. So aligning with that, what kind of quality process, reliability process you have to think of. So totally we have to revamp our strategy for reliability and quality. So this is a kind of scenario we are in. So during manufacturing, during processing, during integration, verification, validation of the vehicles, we have to have different strategies. That's what I am trying to highlight today. See now, what are the drivers for cleaner mobility? Reduce the dependency on the imported fuel, because sometime barrel is $75, sometime $90, sometime $120. Fortunately, we have maintaining good relationship with Russia. We are able to manage it. Otherwise, it would have been more than $100 per barrel. Then it would have had a deleterious impact on our economy. Reduce emission. Yeah, we have a big problem. During winter time, you go to Delhi, literally you will feel choking. You'll have a lot of issues there, breathing issues. What we require to do for making it cleaner? Develop sustainable, cleaner solutions, energy solutions based on renewable. Okay, that's what it is. And then make it robust. People normally, when you buy a vehicle, we'll ask, Will it run for 15 years? The same question will be asked here. Suppose we buy a fuel cell electric car or battery car, will it run for 15 years? That's a question mark. So these are all things, issues we need to address, that's where reliability comes. And then faster delivery of solutions, powertrain solutions. See, now saying that I am developing a vehicle, I take 5 years, sweet time, we may not be able to compete in the market, will become irrelevant by the time we have optimized solutions. So we have to have an agile way of handling it, agile way of verifying, validating it, and then release it to the market, and agile way of addressing to the customer needs, surveys also required. So now agility is more important now. Okay, what are all ways we can make it sustainable and cleaner? See, one is electricity, use the battery, whatever the solar energy which we are harnessing, charge, use it. Another option, only electricity will not be suffice. We need to go for alternate technologies where grid balancing required. For example, solar is available only daytime, probably 8 to 10 hours depending on solar light availability. We can have power generation. What will you do with night? So we have to have a balancing, store it, regenerate it on need based in the night time. So probably battery technology will be useful, hydrogen technology plus fuel technology will be useful. So those are all areas where we need to develop technologies. Already technological solutions are there, but we have to make it, scale it up, make it reliable, robust, cost effective. Those are all areas we need to work on. So now why electricity hydrogen? For example, today we want to generate electricity hydrogen is possible with a coal or using a steam reforming methane we can do. Natural gas reforming can generate hydrogen and electricity. But same infrastructure can be used later on when we are migrating, transitioning from fossil to renewable, it is possible. That is why globally hydrogen and electricity is being considered as an energy carrier. So now the transition is smoother and the same infrastructure could be utilized. Okay, now what are all kind of solution we can look for? For example, fast cars, 300 kilometers less than, BEV, battery electric vehicle is the best solution. Fast cars more than 300, you want to use it as a taxi, fuel cell EV is a better option. Intra-city buses, BEV is option, or FCV is also, fuel cell electric vehicle also option. Intercity buses, coach buses is a fuel cell, battery may not be able to meet the range. If you are going for a 500 kilometer range, then immediately it is something like 5 tons of battery weight will be required. So it is going to be messy and charging time will be nearly more than 2-3 hours is required for restoring charge. So that way BEV is not suitable for long range buses, long range vehicles. Same thing trucks, same logic is applies. LCVs we can think of battery electric vehicle, but it can be fuel cell electric vehicles also, but there is no space for accommodating hydrogen cylinders, battery pack, there is a constraint. Replacement of gasoline engine will be by battery EVs, replacement of diesel engines by FCVs. This is a simple logic in which we can go for it. What is the scenario? How the scenario is there? If it is very fast growth, agility is there in the technology development, and then most of the OEMs and tier 1 suppliers takes up developing technology, giving a cleaner solutions, then 50% is possible. In case automotive goes in the same trend what we are doing it today, then 30% conversion, that is 30% replacement of conventional vehicles with electric vehicles is possible by 2030. So this is a kind of scenario which we can look for. See, now this is a very interesting information here. Two-wheelers, see 20, we can see the numbers. By 2030, two-wheeler totally conventional fuel-based vehicles will not be there in the market. See the three-wheelers, so already 2025, 26, three-wheeler will, most of the autos will be driven by battery. See, take the cars, it will be by 2030. So imagine, these are kind of scenarios which we can look for. If we have this kind of products, then imagine what is the kind of role this quality and reliability we have to come up with. manufacturing of all the aggregates, manufacturing during integration, process integration, all this we need to focus on and we need to develop in case we want to become a global leader. So this is a requirement. There is a lot of opportunity for our youngsters, a lot of opportunity to make our economy viable by internally meeting our requirements. We need not even focus on exporting to other countries. So that is the kind of challenges we are going to have, opportunities. I will not use the word challenges, I will use the word opportunities. See, now this is an interesting slide here. See, there are two layers of energy diagram. One is based on fossil fuel, another is based on totally renewable. Renewable could be hydrogen or electricity. So as I already explained to you, so hydrogen and electricity energy carrier. So whether you are using a fossil or whether you are using a renewable, interlinking is possible. You can commonize the infrastructure. For example, hydrogen dispensing common, electricity charging station common. So this is all kind of commonizing the facilities possible. So one side you have a renewable, one side you have fossil, but there is a slow transition from fossil to renewable without disturbing, it is possible. So that is why hydrogen electricity going to be the future energy carrier. See, this is just to give an idea on, where red color means hydrogen coming from dirty source, coal or steam, methane reforming, or any where we are using electricity also derived from coal. If you use it in the electrolytic process, that is a dirty hydrogen. Suppose you go to the generation of hydrogen using electrolyzer, using solar energy as an input, then it is totally green. So there is a concept is there, whether it is a dirty brown hydrogen, red hydrogen, green hydrogen, grey hydrogen, all the blue hydrogen, the concept is there. But now by 2030, most of the hydrogen generated going to be the electrolytic hydrogen using solar energy. That means going to be green. So already we are transitioning from pink to green, so that the hydrogen generation going to be a cleaner. So now what is the cost of hydrogen? Probably you might be asking, suppose what is the range I will get? Suppose 1 kg of hydrogen is there, intracity bus will run 13 to 15 kilometers per kg. Intercity bus 8 to 10 kg depending on the dry cycle per kg, and per kg hydrogen in the car it will give a 100 kilometers range. So now already fuel cell electric vehicles are cost effective. Running cost is much compared to diesel or petrol, it's comparable, but only initial cost is very high. So we need to work on optimizing the cost, bringing down the cost by localization or making something JV and localize it and make it cost effective and make it affordable. That's where we need to focus on. So these are all areas where we need to invest a lot, and we have to involve youngsters. So we have got plenty of highly capable, talented, skill set people are there. If we could use them, we can deliver. So that is what the kind of delivery we can make. I want to give just one information. In Tata Motors, I had 15 people, youngsters, all came fresh PGTs and GETs from university. With using them, educating them and enhancing their skill set, competency, Nexon EV was delivered within 3 months' time. So imagine if you go to the same thing to FEV or AVL, they would have charged 200 crores, but we have managed within less than 5 crores. That is a kind of affordability we have managed. So that means indirectly what I am trying to highlight is our people are highly capable, they have a sufficient skill set, only give them freedom, guide them properly, they can shape our country. So we can make our country stronger. Stronger sense, economically stronger. We are not intended to take over anyone militarily, but we will economically we can support, and we can do wonderful contribution to the human society. So that's where our spiritual knowledge also will be helpful. We can make globally peaceful, peace process we can bring in, we can make everybody happy. So these are all kind of things which India is highly capable, we can do that. So another slide what I am trying to highlight is just to pictorially showing solar energy, harness, electrolyze it, put it in a compressor, compress it, store it, dispense it, and then run the vehicle. So this is conceptually just one slide I was saying. In the other side, you have a solar panel, generate electricity, charge the battery, run the vehicle. But there is a difference. But we cannot, battery electric vehicle is highly energy efficient, something like more than 70 to 80%. Fuel cell vehicle is 35 to 50%. Still, we need to have hydrogen technology and fuel cell technology because we need to have a grid balancing technology. Without that, it's going to be really difficult. So I got only 1 more minute. So various organizations all over world, they are focusing on fuel cell. So that means indirectly future all diesel vehicles will be replaced with fuel cell vehicles. Why fuel cell? Why battery electric vehicles? I mentioned which range, how to use it. Both are complementing. They are not going to compete. So please remember here. And in case you are looking for a lower range, go for a battery. In case you are looking for a longer range vehicles, go for a fuel cell vehicles. So now we need to focus on fuel cell. I'll just say what are all technology we need to focus on. We need to focus on hydrogen storage and the pressure regulating system. There are a lot of pressure valves, regulators, solenoid valves required to be developed. That is where reliability is going to be there. Fuel cell power system, stack manufacturing, turbocharger, motor-driven turbocharger manufacturing, hydrogen compressor, humidifier, all these required to be manufactured. So many sensors required, pressure, temperature, humidity. Another 1 minute. Then electric traction system, motor controller, traction battery. Battery is going to be a critical technology. We need to develop it. There is a critical things where cell balancing has to be done. While charging, we have to monitor the temperature. We have to monitor the SOC, state of charge. All these things, while discharging also has to be done. A lot of prognostics required to be done. Artificial intelligence is going to play a vital role here for safety of battery electric vehicles and fuel cell electric vehicles. Then a lot of vehicle auxiliary system. Now the compressor runs with the engine and your power steering runs with the engine power driven. But all this has to be replaced with the motor driven, and we have to optimize it, we have to make it energy efficient. So all these are all components which we need to develop and verify, validate. In the case of fuel cell stack, we need to develop a stack, air supply system, hydrogen recirculation filter, air humidifier, and then hydrogen storage system, hydrogen regulation system. There are purge valves, drain valves, water separators, radiator fan specially it has to be made, coolant pump has to be made. All this has to be done, and we have to come up with a cost-effective solutions, reliable, robust solutions, so that it will be affordable common man. So these are all required to be done. Since my time is up, I am stopping here. Thank you for giving me an opportunity to share my view here. Thank you. Thank you very much.
Thank you, doctor. I think the various developments in cardiology, I think it's becoming more an engineering or biomedical engineering now, I think. Thank you, doctor. I think a lot of insight into the various things. And I think Dr. Raja Munusamy really took us through the various, what is there in solar power, how the costs are going to come down, and a very ambitious 2030, he says it will all become electric, and it would reduce the emissions. Hydrogen is going to be the future, and he talked of how Reliance especially is working on hydrogen at 1 rupee or $1 per kg, I think that's what they are talking of. The chairman's dream statement. Because at today's cost, it's about 2.2, 2.3, I think, which is making it a little more expensive than natural gas. And I think all three of them say the people in India are capable. I think that's a big hand for all of us. I think this is the underlying statement from them. So thank you everybody. With this, the session comes to a close. Thank you.
So we are in the end of the second session. Please kindly be here. So now it's time for honoring our chairperson and also the speakers. So now our coordinator of the session, Dr. Srinivasan, will honor our chairperson. Isn't sure for our chairperson. Thank you so much, Dr. Srinivasan. So now our chairperson Ishnover will honor our speakers. So now we would like to honor the first speaker, our Abhilash Chakravarti. Our chairperson will honor the speaker now. Please have a warm round of applause for Abhilash. It's something mix up. Okay. Chairperson will honor our speakers. So our next speaker is, yes, Nagendra Pubati. So now our chairperson will honor our speaker, Dr. Nagendra Pubati. So now we will honor our last speaker, but not least, Dr. Raja Munusamy. Thank you so much, sir.